In this lesson, we're going to explore the topic of percent composition. Now we'll talk about percent composition of normal compounds and also hydrates. Before we get to the meat of the lesson though, we need to first recall molar mass. So please recall that the mass of 1 mole of any element is numerically equivalent to its atomic mass in AMU. So for example, carbon. When we look at the square or the periodic table square for carbon, we see that the atomic mass is 12.01. So that means the molar mass of carbon is 12.01 grams per mole. Now, compounds are a little bit trickier, but the mass of 1 mole of any compound is equal to the sum of the masses of 1 mole of every element in the compound. So for example, carbon dioxide. Well, we know the molar mass of 1 carbon is 12.01, and the molar mass of 1 oxygen is 16.00. So 1 carbon plus 2 times the mass of oxygen gives us 44.01 grams per mole for the compound. That's going to be important when we go about calculating percent composition because you'll need to know how to find the mass of the entire compound. So let's do some practice. Sodium chloride, number 1. Well, sodium is 22.99 and chlorine is 35.45. Add them together, you get 58.44 grams per mole for sodium chloride. Calcium nitrate, well, calcium is 40.08, and there's 1 of them, plus 2 times nitrogen, which is 14.01, plus 6 times oxygen, which is 16.00. So 6 times 16 plus 28.02 plus 40.08 is equal to 68.10 grams per mole for calcium nitrate. Now, tetraphosphorus decaoxide, we have 4 times the number of phosphorus, which is 30.97, plus 10 times oxygen, which equals, so 30.97 times 4 plus 160.0 equals 283.88 grams per mole. Calcium sulfate. Well, we have 1 calcium, so 40.08, plus 1 sulfur, which is 32.07, plus 4 times oxygen, which is 16.00. So 4 times 16 plus 32.07 plus 40.08 gives us 136.15 grams per mole. And lastly, aluminum nitride. Well, 1 aluminum is 26.98 plus 1 nitrogen is 14.01. 26.98 plus 14.01 gives us 40.99 grams per mole. So that's just some review. Now, the task gets a little bit more complicated when we talk about finding the molar mass of hydrates. Well, to find the molar mass of a hydrate, the first thing you do is find the molar mass of the ionic compound like you normally would, find the mass of water, and add the two numbers together. So for copper 2 sulfate pentahydrate, we would first find the mass of copper 2 sulfate. So 1 copper is 63.55, 1 sulfur is 32.07, and 4 oxygens, 4 times 16, add them together, 4 times 16 plus 32.07 plus 63.55 gives us 159.62. I'm going to stop there. I'm going to save the water for later. First, I'm going to calculate all of these ionic compound molar masses first so that we can take care of that. So I'm going to go ahead and pause this video, calculate those molar masses, and then we'll move on from there. Okay, so I've gone ahead and calculated the molar masses of just the ionic compound part of these hydrates. Now, the next step is to calculate the mass of water that we have and then add that to the mass of the ionic compound. So for water, over to the side here, I'm just going to do a little bit of math. Water is 2 hydrogens and 1 oxygen. Well, each hydrogen is 1.01 and oxygen is 16.00. So water, in its chemical formula of H2O, will always have a molar mass of 18.02 grams per mole. So when you're calculating the mass of a hydrate, you are going to just multiply 18.02 by whatever the coefficient is in front of water. So the coefficient is 5 times 18.02. The coefficient in number 2 is 7 times 18.02. Number 3, 4 times 18.02. Number 4, 6 times water. And number 5 is 5. And then the last step is to just add them together. So for copper 2 sulfate, we calculated the molar mass of copper 2 sulfate to be 159.62, and the molar mass of the water that's attached is 5 times 18.02. And if you add those two numbers together, so 5 times 18.02 plus 159.62, you get a mass, and I'm going to kind of write this in a different color here, for number 1 of 249.72 grams per mole. For number 2, 7 times 18.02 plus 120.38 is 246.52. 4 times 18.02 plus 236.43 gives us 308.51. 6 times 18.02 plus 136.28 is 244.40. And lastly, 5 times 18.02 plus 158.12 is 248.22. So that's how you find the molar mass of a hydrate. So the molar mass of the whole compound, including the waters, is what we have written in purple. So it's just 2 steps. Find the molar mass of the ionic compound part, find the molar mass of the water attached, and add those two numbers together. So what's the point, right? Just besides calculating the molar mass, like what are we going to do with this? Well, I told you that the topic of this video would be more so percent composition than molar mass. So percent composition then is like a problem stating, say, how much water is in copper 2 sulfate pentahydrate, or what percentage of water, or what percentage of the compound is copper in copper sulfate pentahydrate, copper 2 sulfate pentahydrate. So those types of problems we're going to be learning how to solve next. So percent composition answers questions like how much carbon is in a mole of sugar or glucose, C6H12O6. Well, the percent composition of any component, so any single element in a compound, is the percent of the total mass of the compound that is due to that component. So what does that mean? Well, the percent mass or percent composition of carbon in glucose is calculated by taking the mass due to carbon, so it's not just the mass of one carbon, but the mass of all the carbons in that formula, so 12.01 times 6, and dividing by the mass of the whole thing, or the molar mass of the whole compound, which in this case for glucose is 180.18, and then you just multiply by 100 to make it a percentage. So the percentage of carbon in glucose, like we said, is you take 12.01 times 6 divided by the molar mass of the compound and multiply by 100, which gives you about 40% carbon by mass in glucose. Here are some example problems for calculating percent composition. Now, the instructions say to look at sodium in each of these 5 examples. So you'll be using Na in all of them except for the last one. Only have 1 sodium in each of these formulas. So what you'll be doing is you'll be taking the mass of 1 sodium and dividing by the mass of the whole compound and then multiplying by 100. So the first example, it's saying, what is the percent composition of sodium in sodium chloride? Well, the mass of sodium chloride is going to be the first thing that we need to calculate, which in this case is 58.44. And then the mass of however many sodiums are in the formula, in this example it's just 1, so 22.99 divided by 58.44 times 100, which gives us 39% sodium by mass. So if we look back at our practice problem list, you'll see that we've solved number 1, leaving 2, 3, 4, and 5. Now, I'm going to put the answers up for 2, 3, 4, and 5, but I want you to check them on your own, and then I'm going to go through how to solve number 5, just to make sure that we're feeling comfortable with the hydrates. So these are the answers you should have gotten doing these problems. If you didn't, make sure you go back and practice and try to troubleshoot where you might have gone wrong, or you might have made a mistake. So the last one is sodium carbonate trihydrate. So again, we're still looking at sodium. This time, however, we have 2 sodiums in the chemical formula. So I'm going to take the mass of sodium times 2. Then I'm going to add it to 1 carbon, 3 oxygens, and then 3 times the mass of 1 water, which gives me a molar mass total of 160.05. If you're not sure how I got that number, go back to the beginning of this video and rewatch the molar mass of hydrates. So if I take 22.99 times 2, so the mass due to sodium, again, in this formula, it's not just 1 sodium's mass, it's the mass of all of the sodiums in the compound, divided by the total mass times 100 gives us 29% sodium by mass. And that's about it for percent composition. Most of the problems that you see will probably not be hydrates, but there will be some where you do have to do the calculations involving the water molecules being attached. So just make sure that you're feeling comfortable solving for the molar mass of compounds, including hydrates, and then taking that one step further and solving for the percent composition of one of the components. The most important thing that I can tell you is that when you get to this step right here that I'm circling in blue, is that you don't just put the number from the periodic table. You have to take that number from the periodic table, look back at your original formula, see how many there were of that element that you're being prompted to look at in the problem, and multiply those 2 numbers together. Because the mass due to that component isn't just one of them in this case, there's 2 of them. So if you have any questions, feel free to email. Make sure that you're feeling comfortable doing molar mass of hydrates and then percent composition.